Hello. Now we are going to look at construction 13. And in construction 13, we construct a right-angled triangle given the length of the hypotenuse and one of the other sides. So we have several bits of technical language there. We have a right-angled triangle, means one of the angles in the triangle will be 90 degrees. And we also have hypotenuse. And we're going to come back to the meaning of the hypotenuse in a minute. It's going to be the longest side in our triangle. And we'd also know that it's across from the 90-degree angle. But where that will come up is when we draw our sketches before we start doing our formal construction, and the hypotenuse will become clear at that point. So looking at our geometry notation, we have our triangle symbol for the triangle we're going to construct is going to be the triangle with the corners A, B, and C. A, B, and C are capital letters for points, and the corners of our triangle are called vertices. The distance from A to C, the points A to C, or the vertices A to C, the distance is from our vertical lines on either side. That's going to be 13 centimeters. The size of the angle from A to B to C, so if we walk from A to B to C, that angle will be 90 degrees. That's our right angle that was referred to in the construction title. And then the distance from B to C is 5 centimeters. So now we need to start doing our basic sketches of our triangles. So we are going to start off with a triangle that has no attempt at being the right proportions. We just want to get the information we have down on something roughly triangular to get a feel for where we're going. So we have AC is 13 centimeters, so from A to C is 13. The size of the angle from A to B to C is 90 degrees. So that angle there should be 90 degrees. And B to C is 5. So we can see our initial diagram is very off, but that's fine. We're going to redraw it now, and we're going to start off with our horizontal part. So I'm going to draw in a little line for BC. A little line in for BC. And that's going to be my 5 units. That's B and that's C. And I want to go up perpendicular from B. I'll go up fairly far because I know that the slopey part of this has to be 13 long. So coming from A down to C is supposed to be 13. So I know I have a 90-degree angle in here. I could use my 90-degree symbol in there, which is just a box. I could also draw a capital L in that corner, and that would mean the same thing. So that is roughly what our diagram should look like. So let's get into our formal construction. We're always going to start, if we can, with a horizontal line. So I'm going to start with BC, or sorry, before we do that, now we've drawn our diagram in, we can immediately see what the hypotenuse is supposed to be. So by drawing our rough sketch, I can see that the side 13 ends up across from my 90-degree angle, so it must be the hypotenuse. So our construction requires us to know we have a right angle triangle, we've got that. We need to know the hypotenuse length, so that's across from the 90-degree angle, we've got that. And then we need to know another side, so either this side or this side, and we know BC. So now we're going to draw out our side BC as part of our construction. So we will grab our ruler and we will start here, and we're going to draw over neatly at 0 and go across to 5, and I'm going to put some points there to keep track of exactly where I'm going. So there and there, that's B to C. Now if I can get my ruler out of the way for a second, so I'm going to label that so I don't get muddled. I'm going from B to C there. Now I know going from BC I want to come up some distance 90 degrees from the side BC. So I could use a set square for this, but it's more accurate to use a protractor because the edge of the set square is a little bit rounded at the edge. It can be a little bit difficult to get it to sit exactly where we want. So what we're going to do is put where all of our angle markers go down, to a point, that's where we're going to line up B, and we're going to make sure that the line BC is along the 0 degrees angle. and then we're going to go up to 90 degrees. So as neatly as we can, there. So we have our mark in there, and now we're going to draw a line up from BC, going through, or sorry, a line up from B, I should say, going up through there. And we want to give ourselves lots of distance for this. We know that it's going to be quite long, so give ourselves as much space as we possibly can. We know that A is going to be somewhere along that line, because we know A is going to go perpendicularly up from the line segment BC. What else do we know about it though? It's going to be 13 centimeters away from A. So how would I get a distance away from C, I should say. A is going to be 13 centimeters away from C. So how would I get that on my, how would I figure out where that was? Well, I want to know a distance away, but I don't know the direction. So my compass would be the most appropriate tool for solving that problem. So put the point of the compass at 0 and open it up to 13. And now I'm going to get my straight edge out of the way for a second, and put the point of the compass down at C. And I know that where I'm interested in, and my green line, has to be 13 centimeters away from C, and it has to be on the green line. So if I combine those two facts, I know A has to be on this arc. It has to be 13 centimeters away from the point C, and I know it has to be perpendicularly away from BC through B. So A has to be the crossing of those 2 points. It has to be true for both of those things, so A has to be up there. So now I'm going to draw in my line that connects up to that arc. And when I do that, I'll see that it ends up being 13 units, and it's crossing where I need it to. So I'm going to change my color there, draw in my line, and now I have my construction completed. I'm going to mark in my point. I'm going to mark in my point A. So A has to be there, because that's where both of the facts I know about A converge. So I have completed my construction now. I want to label what it is I know. So I know I have a 90-degree angle in here. I know that this distance here is 5 centimeters. I know that this distance here is 13 centimeters. Now I can see when I draw in what I know that this is a little bit different to the information I've had for my other constructions. So why is this going to work? Why does knowing an angle and the side next to it and then a side further away? Ordinarily, for a triangle in general, that would not be enough information to accurately draw a triangle. I would need to know 2 sides and the angle in between, or I would need to know a side and the angles on both ends of that side. Or I'd need to know all 3 sides. I don't have that information here, and yet I'm able to draw my triangle accurately and exactly. So why am I able to do this? And it's connected to the fact that this is a right angle triangle. And I'm going to make the claim that this is basically the same as having all 3 sides of our triangle. And it's important that we think about how what we get here links back to what we know from our work in geometry and our work in trigonometry. So this is enough information to exactly and uniquely draw a triangle. And in congruence, we would say it is right angle, hypotenuse and side, so RHS. And that's enough information to say the 2 triangles are identical if we know this information. But it's important that we link back to what we know and say, why? Where can we go from what we know about constructing triangles, what we know about right angle triangles, and connect the dots to see why this construction is working? And that is what we need for now.